In the winter of 2005, on a research ship rolling over the North Atlantic, a team of scientists crowded around a screen and watched something no human being had ever seen before. They'd hauled up a sample from a seamount thousands of meters down, an underwater mountain in permanent darkness, where the water sits a hair above freezing and the pressure would flatten a submarine. Tangled in what they'd collected was a single egg. And as they watched, the egg moved. Something pushed its way out into the cold. But it wasn't the blind, helpless speck they were expecting. What emerged was a tiny, perfect octopus, fully formed, every arm in place, two little fins already flapping, calmly swimming off as though it had been doing this its entire life. A newborn animal, born ready for the most hostile environment on the face of the earth. It was the first time anyone had ever filmed a deep-sea octopus being born. And it raised a question that's far stranger than it first sounds. How does anything begin its life down there, in the dark, in the cold, under all that crushing weight, and come out ready to survive on its very first day? The animal in that egg was a Dumbo Octopus. We named it after a Disney cartoon. We turned it into a meme. The cute little flapping elephant of the sea. But that cuteness is a costume. Because the closer scientists have looked at this creature, the stranger it has become. It can't squirt ink. It can't change color. It swallows its food whole, and it lives deeper than any octopus has any right to live. Every soft, silly-looking thing about it turns out to be a tool, forged for a world we are only just learning how to reach. In this video, we're going down, following the Dumbo Octopus, from the deck of a Victorian sailing ship, where the first specimens were dredged up and quietly filed under the wrong name, all the way to a record-breaking dive that proved this animal can survive where we thought nothing with a brain could. We'll take it apart one strange feature at a time, because each one is the deep sea solving a problem. And we'll end on the deepest question of all, not just how deep life can go, but how much of it is still down there, in the dark, that we have never seen. Let's start with the only thing most people know about it. The ears. They're not ears, of course, they're fins. Two soft flaps sprouting from the top of the body, right above the eyes. And they are the entire reason this animal has the name it does. When footage of one first reached the public, there was really only one thing to call it. Disney's Dumbo, the 1941 cartoon about a baby elephant who flies on a pair of comically oversized ears. An octopus came up from the deep doing almost exactly that, and the nickname stuck so hard it now appears in serious scientific writing. But here's the first twist. On any normal octopus, those fins would be useless. A shallow water octopus moves by jet propulsion. It sucks water into its body and blasts it out, rocketing backwards in a burst. It's fast, it's dramatic, and it burns a colossal amount of energy. Down where the Dumbo lives, where your next meal might be days or weeks away, burning energy like that would kill you. So the Dumbo doesn't do it, it flaps. Those ear fins beat in slow, deliberate strokes. The webbing between its arms pulses open like a tiny umbrella, and the animal effectively flies through the black water in slow motion, sipping energy instead of spending it. The thing we find adorable is actually a fuel-saving system, built for the hungriest neighborhood on the planet. And that is the pattern for this entire animal. Hold that thought, because the next feature isn't just efficient, it's eerie. Picture everything an octopus is famous for: the ink cloud it fires to vanish, the skin that flashes through colors in a heartbeat, the way it melts into the exact texture of a rock. Octopuses are the great illusionists of the sea. The Dumbo octopus can do none of it. It has no ink sac at all. It has lost the working, color-changing cells, the chromatophores that let other octopuses put on their light show. It cannot turn invisible, cannot flash a warning, cannot disguise itself. On paper, that sounds like an animal that's been robbed. But ask the obvious question: who would any of it be for? Thousands of meters down, there is no light, none at all. An ink cloud is a smokescreen, pointless if nothing can see you to begin with. A flash of color is a signal, pointless if there are no eyes around to read it. Camouflage is a costume against a backdrop, and down here the backdrop is pure black. So evolution did what it always does with expensive equipment that nobody's using. It stopped paying for it. The Dumbo didn't lose these tricks by accident. It abandoned them because in total darkness they were dead weight. And that's the moment the cartoon falls away. This isn't a simplified, lesser octopus. It's a specialist, re-engineered so completely for the deep that the things we think define an octopus have simply been deleted, which leaves one obvious problem. If this creature is so perfectly built for the bottom of the world, how did we ever get our hands on one in the first place? The answer is a story of more than a century of getting it wrong. It begins in the 1870s, with a ship that more or less invented the study of the deep ocean. Between 1872 and 1876, HMS Challenger sailed around the world, dragging nets across the seafloor at depths no one had ever sampled, hauling up creatures so alien that Victorian science had no boxes to put them in. Among that haul were strange, flabby, finned octopods, and the first Dumbo specimens almost certainly came up in those nets. But nobody recognized them for what they were. They were lumped in with other deep-sea octopods under the wrong names, labeled, shelved, and largely forgotten. That was the curse that hung over this animal for decades, and a lot of it comes down to one cruel physical fact. A Dumbo octopus is built like a water balloon. Most of its body is soft, gelatinous tissue, tuned precisely to the cold and the immense pressure of the deep. Drag one up through kilometers of warming, decompressing water, and it doesn't arrive as a specimen. It arrives as a ruined blob, half melted, its delicate shape collapsed. For generations, scientists were trying to reconstruct one of the ocean's most graceful animals from what amounted to a deflated bag in a jar of preservative. Still, they pieced away at it. In the decade after the Challenger returned, museum naturalists worked through its enormous biological haul and published the first careful descriptions of these finned octopods, proof that they were a real, recurring part of the deep-sea world, not a one-off freak. And finally, in 1932, a zoologist at the British Museum named Guy Coburn Robson gathered the scattered specimens together and gave the group its own scientific name, Grimpoteuthis, named in honor of a German cephalopod specialist, Georg Grimper. So 60 years after the first one came up in a net, the animal at last had a name. What it still didn't have was a life. Nobody had ever truly watched one behave, how it moved, how it fed, how it bred. You cannot learn that from a corpse. To understand the Dumbo octopus, you couldn't keep dragging it up into our world and watching it die. You had to go down into its... And once we did, once submersibles and deep-sea cameras started landing on the seafloor, the Dumbo gave up its secrets one quiet surprise at a time. Take something as simple as eating. A normal octopus is a hunter armed with tools, a hard, parrot-like beak it uses to bite, to crack shells, even to drill into them. It's precise, violent work. The Dumbo throws that rule book out too. It drifts down onto the seabed, spreads its webbed arms over the mud like a net settling, and uses tiny finger-like projections along its arms called cirri to flick small prey inward. Then it does something almost no other octopus does. It swallows them whole. Worms, copperpods, little shrimp-like crustaceans, gulped down entire, no cracking, no fuss. And it makes perfect sense in a place this starved. When food is this rare, you cannot afford to wrestle it or be fussy or waste a single calorie. You spread the net, you sweep up whatever the dark provides, and you take it down in one. Even the way this animal eats is shaped by hunger. But the strangest thing the cameras revealed wasn't how it feeds. It was how it makes the next one of itself, and it's the answer to the egg we watched hatch at the very start. On the surface, the calendar runs everything. Animals breed when it's warm, when the light comes back, when the food blooms. It's a schedule written by the sun. The Dumbo octopus lives in a world the sun has never touched. No spring, no summer, no signal in the water that says now is the time, so it ignores the calendar completely. Open up a female, and you'll find eggs inside her at every stage of development at once, some tiny, some nearly ready to lay. She is, in effect, permanently prepared, able to release a mature egg the moment conditions allow. Because in a place this empty, an encounter with a mate might be a once-in-a-lifetime event, and she cannot afford to be caught unready. When she does lay, she cements her large, tough-shelled eggs onto something solid down there, often the branches of deep-sea coral, and leaves them in the cold and the dark to develop slowly, with no parent watching over them. And there is no fragile larval stage drifting in the current, hoping to find food before it starves. When a young Dumbo finally pushes out of that egg, it comes out exactly the way the team in 2005 saw it. A complete miniature adult, every system working, ready to hunt from its very first second in the black. Think about what that means. In a world with no seasons, no light, and no second chances, this animal stripped every vulnerable, gambling step out of its own beginning. It doesn't bet its young on a drifting larval lottery. It releases them finished. Every layer we peel back, the cartoon gets tougher and stranger and more deliberately engineered. And just when scientists thought they understood it, the deep handed them something that broke the size chart entirely. For most of this story, a Dumbo octopus would sit comfortably in the palm of your hands. Most are around the size of a dinner plate. The very largest ever recorded reached something like 8 meters, but that's a rare exception. This is, by and large, a pocket-sized animal. Then, from a seamount in the North Pacific came a specimen that didn't fit. It was noticeably larger than its dinner plate cousins, with proportions unlike anything in the genus, and the scientists who described it, Alexander Ziegler and his colleague Christina Sagorni, gave it a name worthy of its size. Grimpoteuthis imperator, the Emperor Dumbo. But the breakthrough wasn't really how big it was how they studied it. Remember the curse that hauling one up destroys it, and dissecting it destroys it again. So, this time, instead of reaching for a scalpel, they reached for a hospital. They ran the entire animal through MRI and CT scanners, the same machines used to look inside a human patient, and built a complete three-dimensional digital model of its organs, its nerves, its insides, without so much as a single cut. The specimen survived intact. The science got done anyway. After 150 years of melted blobs in jars, we'd finally found a way to truly see a Dumbo octopus without destroying it. The animal had a name, a life, and now an unbroken body to study. There was only one frontier left, the one thing the Dumbo had never let us measure, just how deep it would go. There had always been an unspoken ceiling on this animal, a deepest known point below which we assumed even it couldn't survive. The Hadal Zone, everything below 6,000 meters, was thought to be off-limits to complex animals like octopuses. Too cold, too dark, too crushing for something so soft. Then came the 5 Deeps expedition, an audacious mission funded by the explorer Victor Vescovo to send a crude submersible to the deepest point of every ocean on Earth. And on its Indian Ocean leg, as cameras dropped into the Java Trench, the Dumbo octopus answered the question for good. First, at 5,760 meters, one of them drifted calmly across the seafloor, already a record. And then, deeper still, at 6,957 meters, another one, flapping those soft ears across the floor of the trench as casually as if it were out for an evening stroll. To put that into perspective, you could drop Mount Kilimanjaro into that water and its summit would still be drowned a kilometer beneath the waves. The pressure down there is around 700 times what you feel at the surface. The weight of a small car pressing on every square inch of your body. When the marine biologists Alan Jamieson and Michael Vecchione published the find, it wasn't just a personal best for one octopus. It was the first solid filmed proof that any cephalopod, octopus, squid or cuttlefish could survive in the Hadal Zone at all. In a single dive, the known limit of where these animals can exist was pushed downward by more than 1.5 kilometers. And the creature that smashed it wasn't some armored nightmare of the deep. It was the gentle little Dumbo of the sea, built, it turns out, for a place we never even thought to look. And that should give us pause, because of what it says about how little we actually know. The deep sea is the largest living space on our planet, and it is also the least explored. We have better maps of the surface of Mars than of these trenches. Every single time we lower a camera into them, the rules we'd confidently written about where life can survive turn out to be guesses, and the Dumbo octopus keeps proving them wrong. Almost every major discovery about this animal in the last 20 years, the hatchling, the emperor, the record dive, was a complete surprise, which matters more than ever right now. Those same abyssal plains where Dumbos live are carpeted with potato-sized metal nodules, rich in cobalt and nickel, and companies are building machines to vacuum them off the seafloor for batteries. We are getting ready to bulldoze the deep before we've even finished finding out what lives there. An animal that breeds this slowly in a place this fragile would not recover from that in our lifetimes or our grandchildren's. So the next time the Dumbo Octopus drifts across your feed, that adorable flapping ghost, captioned like a joke, remember what you're really looking at. Not a cute accident, not a lesser octopus that lost its ink and its colors. You're looking at a creature that threw out the entire octopus playbook, the ink, the color, the jet, the bite, and replaced it piece by piece with tools for a world of permanent dark and crushing weight. And it's even tougher than the memes suggest. You'll sometimes hear it called helpless, hunted, doomed in a hostile abyss. In truth, it has barely any predators at all. Its world is so empty that the real danger isn't being eaten, it's simply finding enough to eat. You'll also hear you could keep one in an aquarium. You can't. Bring a Dumbo to the surface and the loss of pressure and the warmth kill it within minutes. It cannot leave the deep. It is the deep made into an animal. What gets me about the Dumbo octopus is how patient it made us be. For 60 years it was just a wrong label on a museum shelf. The truth only came when we stopped dragging it up into our world and started, carefully, going down into its. With cameras, with submersibles, with scanners borrowed from hospitals. Curiosity and patience, and slowly a cartoon turned into one of evolution's quiet masterpieces. And the deep is full of creatures still waiting for that same patience. If you'd like to keep going down there with me, to the next animal that shouldn't exist and somehow does, subscribing is how you make sure the next descent finds you, and the Dumbo is nowhere near done with us. New species are still being named, one as recently as last year, pulled from a seamount almost nobody had ever surveyed, named for the flying celestial dancers painted in ancient Chinese caves. There are 17-odd species we know of, and that number keeps climbing every time we point a camera somewhere new. Somewhere in the dark right now, in a trench no lander has ever reached, there are almost certainly Dumbo octopuses we've never seen, doing things we can't yet imagine. If you made it all the way down here with me, thank you. Drop an elephant emoji in the comments for the strangest little flyer in the sea.